Hello there. This is the second in a series of three videos who describe the different parts of an electrical protection system. In a separate video, it will be more useful, naturally, to include pictures. However, this is simply to describe and rather than show the practical side of it, which would be more useful in a different setting, this is just to describe. So, whilst I do acknowledge there are different types of equipment for circuit breakers, fuses, relays, voltage transformers, current transformers, etc., this is simply just to describe in a small amount of detail. So, as you can see on the screen, and relating to the previous video, relays are a common part of electrical systems, and they help with detecting electrical faults and based on a certain input and a curve, they will help a device disconnect a faulty circuit. So ultimately, they offer protection, and without them, circuit breakers, for example, will not be able to trip, and therefore this could allow a circuit to remain connected and cause damage to a downstream circuit. They are able to sense abnormal conditions and readings, such as an excessive current for a prolonged period of time, which is known as an overcurrent. It can detect overvoltages, undervoltages, and most importantly, they trigger an action which, as just mentioned, it would be to disconnect a circuit, for example, by energizing the drip coil of a an air circuit breaker. So when the conditions are met for a certain percentage of overcurrent for a certain period of time, the signal will be sent from the relay to the breaker to cause the breaker to trip, disconnect the circuit, and then prevent any additional damage, both upstream and downstream of the circuit breaker. There's many different types of relay, and as a few of them are mentioned on screen, there are electromagnetic, thermal, solid state, differential, UV/OV, which stands for undervoltage and overvoltage, and OCEF, which is the most common in substations, as an overcurrent and earth fault. There are more than these available, and each one has its own individual uses. For example, you get electromagnetic and thermal inside of little miniature circuit breakers. So that's not to discredit anything. Okay, so following on from that, to aid the actual relay in monitoring voltage transformers, based on what we just have on the screen, they are a means of converting a voltage. So if we take the example of using the bus bar voltage inside of an 11,000 volt switchgear enclosure, then we would have the voltage transformers taking that high voltage and converting it to a low voltage, let's say, for example, 110 volts. So in that case, it'd be a factor of 100 to 1, where we reduce that voltage by a factor of 100 to get it to 110 volts. This is so that it's more manageable and is also able to still be used for the likes of monitoring the overall voltage at a more easy to manage level. Additionally, it can be used for the likes of electrical system protection, for monitoring any voltage disturbances or system stability issues. For example, voltage transients can occur where a sudden peak in the voltage can cause a lot of disruptions, whether that's nuisance tripping or electrical equipment to be damaged. And on that basis, we really need to be having a sort of scheme which prevents this nuisance tripping. We need to be finding out what is causing this sort of transient. But more importantly, we need to have a good electrical protection scheme. When it comes into the actual applications of the voltage transformer, so common examples, which could be with the likes of having a solar farm connection, can use an undervoltage or undervoltage protection, where in the event that, let's say, it's a raging hot day and the sun is out and it's fantastic, the solar farm is producing its best ever yield of power, and you get a massive overvoltage. Your system doesn't like this. Suddenly, the protection activates because the voltage transformer is feeding its reduced voltage. The relay is monitoring this, and the other voltage relay activates. Ka-chunk, disconnected. So your system is protected from away from the solar farm. Job good, all done. Um, Additionally, it can be paired with the likes of a current transformer for differential protection or distance protection. Distance protection for the likes of transmission lines, and differential protection for the likes of zoning. So they do have a fundamental part, and they need to be used correctly too. But like I said, this is just a brief call over different components. So what I just mentioned current transformers. These current transformers, just like the voltage transformer, step down a measurement, but this time it's a high current to a more manageable um, current. So again, it could be by a factor of 100 or 500, or it all depends on what you have designed your protection scheme to, and also what equipment you are using and the relay, and it needs to be carefully considered, the ratio in particular. Um, we have different applications for them as well, and another bit which needs to be taken into account is the burden. But that could be a topic for another video, specifically going over current transformers. This is just a quick, brief overview. So, reducing this high current to a manageable level, we use CTs for overcurrent protection. We use them for transformer protection. They allow relays to detect short circuits, overcurrents, such as overloads, and they trigger a relay to respond and disconnect a circuit. As mentioned in the last slide, they're used in conjunction with voltage transformers, differential protection, and distance protection. They can provide feedback for control circuits, and they can also be used to monitor energy usage, not just for billing, but maybe if you wanted to be able to do a bit of planning. So, maybe you want to change your network. Pardon me. Maybe you want to change your network, or maybe you want to plan an electrical outage. Well, let's see how much current is actually on the network. Well, it actually consumes 600 amps on this period. Well, we're going to have to either redistribute it by another means, which would be done through a resilient electrical system, or you can do it by saying no, we can't do it. It's going to have to be delayed, which can happen a lot until an alternate means is possible. So there it is, the use of a current transformer. So overall, we had the relays, voltage transformers, and as you can see, it's still on the screen, current transformers. And they are the backbones of electrical systems, not just fuses, not just circuit breakers. They can't, especially circuit breakers, cannot act without relays, voltage transformers, and current transformers. They make sure the system is safe, that everything runs smoothly, and effectively, they allow for the monitoring and controlling of current and voltage. Therefore, they are the key components, besides another component called the lithium batteries, of which none of this can happen without. So, thank you very much for listening, and this is the second of three sort of electrical podcasts. So, thank you very much for listening. Goodbye.